stuff like that to keep like the symbols and stuff.
It always has to be like, well, 1 point something or 5 points. So
Practice recording on.
Okay, so it can't be like.
Point something.
even if it's times 10.
So would I do it that times?
Stop.
Yeah, you have to make it times 10 or whatever.
Oh, so it ends up
Your
being like.
mantissa still has to have a number in front. It's supposed to be times 10 to something.
So would it be like
Times 10 to,
one?
can I say it?
Yeah.
So this.
Times 10 to the 0 power.
Yeah, it would just be 4.56 times 10 to the 0 power. And your calculator, you can actually cheat. Your calculator has a convert to scientific notation function. So you can plug it in, then you can go to mode and make your calculator scientific notation. So when in doubt, use the tool you got. Use your calculator in front of you.
Okay.
So 0.021291. So how many places did you need to move it? -2 places. Oh my gosh, my button. Okay, come on, button. 2.91 times 10 to the -2.
I just have to.
How we feeling about this so far? We good? Okay. 8,956. How many places did you need to move this one?
3.
3 places. So 8.956 times 10 to the 3rd.
Yeah.
And 583.50. Did you keep the 0?
No.
No, after the decimal you keep it.
You should. Yeah, you should keep the 0.
Why should you keep
I thought you said it wasn't significant.
It is significant. This 0 is significant. These guys are not, and we'll talk about this in a little bit. Plant some seeds. So these guys are not, this one is. Imagine you weighed something that weighed 583.5 grams, but you weighed it on a balance that went out to the hundredths place. Okay? So imagine you weighed something that was exactly 583.5 grams, but you weighed it on something that went out to the hundredths place. You're basically telling the reader that you weighed it on something that had a precision that went out to the hundredths place. If we weighed it on something that went out to the thousandths place, it would have another 0 there, so we need to keep the 0 here. So that 0 after the decimal is a number of precision. You're basically saying, my equipment was this precise, so we don't want to lose precision in our conversion. Does that idea make sense?
Yeah.
Okay. Now, 360,000, let's say you sold your house, your parents sold your house, and they sold it for 360,000 and some change, and there was taxes and fees in there, and you're like, how much did you sell your house for? 360,000. It's not the exact number. Those extra zeros are just kind of rounding and approximation numbers, so they're not important. So in the second case, we don't keep the zeros because they're not important. And my button is not damaged somehow.
That'd be sad.
Yeah, I've had this button for like 20 years. This is a really old button. I have to track something else down. Look, it even has duct tape on it to tell you it's really, really old. Oh well, anyway. So 3.6 times 10 to the 5th. Okay, how are we doing so far? Give me a thumbs up if you're comfortable. Put your hand and wave in the air if you want to talk about it some more. Most of you are comfortable? All right, so let's go the other way.
Oh wait.
Oh, snap.
But I'm still counting on the thing. I'm like, it's still going to work, right? But obviously not. I put a new battery in it. Something's wrong with the transmitter or the receiver.
Loading point notification.
It's loading. I'm going to take my transceiver or my receiver up here and see if that does anything at all. I'll take my transmitter up to the top of my monitor, and maybe that'll remove any kind of weird electromagnetic interference.
So that's the other way? Yeah, it does.
Here we go. Now the receiver is sticking up. Let's see if it makes any change at all. Maybe. on the physics toolbox thing, I know for sure it works on Android. There is an Apple version, but I don't know what functionality the Apple phones have. I'm under the impression they have less sensors, but yeah. There's sensors in my phone, I didn't even realize I had. When you're in English class, everybody take out your phone and download it.
I got that next hour, so I'll do it.
GoPro mounting equipment. Right now I'm trying to remember if it's mine or if it belongs to Rodney. Because Mr. Ball gave me the GoPro 3 years ago to record lectures, and I bought a bunch of stuff, and I can't remember if it's mine or if it belongs to him. So I'll probably just give it to him either way. All right, so it sounds like from the chatter that you're ready to move on. So 8.52 times the negative 4. Negative 4, big number or small number?
Small number.
Small number. Yes.
Oh, okay. I'm actually starting
Look good?
to get this one.
1.1 times 10 to the third, big number or small number?
Big.
Big number.
Okay, rad.
3.91 times 10 to the minus 2? Small.
Small.
Just have to press the button for a long time. Okay.
Rad.
And then 6.5 times 10 to the 0. Yeah, it's just 6.5, right? I think we're gonna have to. I think we're definitely gonna have to invest in a new button. Screen. That's done. It's done. The poor thing is toast. Okay. So 6.5, and then 6.3 times 10 to the 6th. Look at all those zeros. Okay, you have to put those zeros in to make it 6.3 million, but they're not significant. So you can see going from this to this, this to this, you can see the relationship, those extra zeros. Zeros that make a number really big are not significant. Okay, how are we doing so far? Give me a thumbs up if you're happy with what we're doing so far and you're ready to move on. All right. Question?
Yeah, can you never, like, if you're doing giant implementation, you should always have one with one, like, always one.
Yes.
You can't have two?
Correct, yeah. You should always have one number in the mentism.
Oh.
Yeah. One number, decimal, and whatever's left over.
Okay.
Okay, we're going to talk about scientific notation and then significant digits. I want to skip over this and come back to units so we can just get to significant digits. There we are. Okay, so here's rules. I'm not a big rule fan, but here are the rules with significant digits. So obviously all non-zero numbers are significant, right? Zeros between non-zero numbers are significant, and zeros to the right of the decimal are significant. Zeros that push a number really big are not significant. So zeros to the left of a decimal are not. I don't really like this idea. I don't like this rule because I don't see a decimal in there. But if you like rules, those are the rules. And I'm going to show you a trick here on the next slide. A trick, not really a trick, a strategy, if you will. I can put my helmet somewhere. Fortunately, I think that hook is inextricably linked to the center board. Can't put it anywhere but right there. we're going to blow something up, we'll wear this. We're going to be safe. He has a fireman's helmet. All right, so those are the rules. If you like rules, those are the rules. Most important, the trickiest thing is if a number decimal has zeros, those zeros after the decimal are significant because they're numbers of precision. They are significant. Zeros between significant numbers are significant, and the zeros that push a number bigger is not significant. And here's the fun little trick. You ask yourself, is the decimal present? So when you're looking at a number and determining how many significant digits it has, you ask yourself, is the number significant? Or sorry, is the decimal present? If the decimal is present, then you count from the Pacific. For instance, 31.80 and 0.0020, just looking at it, think about how many numbers of significance this one has. And I'll ask for fingers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if this one had, how many numbers of significance does this have? Show me with your fingers. 4, 4, 4, 4, 4, 4, 4, 4. Yep, 4. Because you start counting from the Pacific and it has 1, 2, 3, 4 digits of significance. Make sense? Now look at the next one. How many numbers of significance does the next one have? And this is where the trick comes in really handy. 4, 4, 2, 4, 2, 4, 4, 2, 4. It has only 2. It has only 2. And if you were to write this number in scientific notation, you would write it 2.0 times 10 to the minus 3.
I thought it said zeros to the right of the decimal are significant.
I know, that's why the trick is easier than the rules.
Bruh.
You have to do the rules, you have to do the rules in order and it's just annoying. So that's why this is easier. So yeah, so these numbers just put the number bigger or smaller, and when you convert it into scientific notation, it's like, okay, I can see that because it's 2.0 times 10 to the negative 3. There is no way to write these numbers in scientific notation. Can you see that? Yeah. There's no way to add these zeros in scientific notation. So when you convert it to scientific notation, then it's like, oh, I can see how it's only 2. Okay. Should we do some more? Now, if the decimal is absent, from where do you count?
Absent.
Yes. You should count from the Atlantic. Yeah. If the decimal is absent, we count from the Atlantic. So here are 2 numbers where the decimal is absent. See if you can figure out how many numbers of significance 56,430 has. Quattro. It appears quattro appears to be the consensus, and yep, it has quattro. And if you wrote this number in scientific notation, the number you would write would be 5.643 times 10 to the 4th.
Okay.
What about the next one? See, you're picking it up. 3, 2, 3, 3. This would be 1.07 times 10 to the 4th.
Okay, right.
So, figuring this out?
Yeah, kind of.
Are you getting comfortable with this idea of significant digits?
Yeah.
Okay, so what I'd like you to do, not now, but soon, I want to see how much of the lecture we can get done. If it's homework, great. If it's not, that's great too. What I'd like you to do in your significant digits worksheet is take your calculator output and looking at how many significant digits the numbers have to begin with, round to that number of significant digits. Now here's the thing. If you take a number that has 3 and you multiply it by a number that has 2 numbers of significance, how much should the answer have?
2.
2. Okay. If you have a number that has 5 numbers of significance, and you multiply it by a number that has 2 numbers of significance, how much did you answer have?
2.
2. Okay? You cannot create precision. Does that make sense?
Yeah.
The best we can do is a number with the same amount of precision. You cannot create precision. Okay? Just like if you took your neighbor's homework and you photocopied it, the best you could do is the exact same copy. You can't make it more clear. You can't make it better. You're like, I made a copy and all the answers became correct. You can't do that. You can't make a copy of a copy and have it even better than the original. Okay. So if you have a number with 2 numbers of significance and another number with 4, you don't average them, the answer should have 2. Cool?
Yeah.
Give me a thumbs up if that sounds comfortable to you. All right, so we're going to backstep a little bit, talk about standard units, and then we will finish up. And any extra time you have, you can work on your stuff. All right, standard units. Okay, in physics we use standard units, and we only use standard units, with the exception of the liter. Every now and then we use a liter. But you're probably coming from chemistry where we use grams. We don't use grams anymore. Everything is kilograms. Okay. So just like in your lab, you measured your cart to bounce, spit out a number in grams, you convert that to kilograms. Oh, I'm going to pass back your lab today too. So you did just fine. Okay. So those are your standard units: meter, kilogram, second, Kelvin. Again, the liter is technically kind of a wishy-washy standard unit for volume. We will sometimes use the cubic meter, the volt, and the Newton. These are standard units. So copy that down as I pass out your paper. I'm going to give to the person, if you gave me a packet, I'm going to give it to the person whose name is on the front. So just to make my life easier. Excellent question. Okay, so functions and irrational numbers. Good question. How many numbers does pi have? Infinite. So pi does not care about significant digits, or because it goes on forever. Okay, and in addition to that, okay, does that make sense? So when you see pi, it has as many significant digits as it wants. Here's the crazy thing about pi. Pi is technically a ratio. It is a function. It's not a number. Okay, that's pi. That's the ratio of circumference to diameter. In fact, if you ever don't have a pi button, like you need to do pi, but you only have a 10-key, basic calculator, 22/7 is pi. So pi is technically a function, not a number. So does that mean it only has 1 digit? No. Functions have as many as they want. Irrationals and functions have as many as they want. So pi has as many as it wants.
That's interesting.
Yeah, pi is not a number. Pi is a function. A ratio of circumference to diameter of a circle.
So like on our moment, it's a 25 to 5 is one of them. So
It'd
that
be
would
just 2.
significant.
Yeah. The 25 would have 2, and you answer with 2. Very good question. Also, counting numbers. Numbers that have a definite value, like the mole, 6.022, blah, blah, blah. The mole has as many as it needs. Okay? Anything that is a counting number or a ratio, that also doesn't count, if you will. For instance, 4 dozen is technically 48. That has 2 significant digits, because a dozen is a set number with infinite, with perfect precision, if you will. Okay? When I say a dozen, you know exactly 12. There's no question mark in there. It's 12. So you don't say 4 dozen is just 4. You say 4 dozen is 48. That has 2 significant digits. Does that make sense? So if something has a definite value where there's no question in its precision, then it ignores significant digits. Hey, the Kelvin scale, yay. Celsius plus 273 equals Kelvin. It's on your formula chart. I don't know why they put it on your formula chart. maybe somewhere out there, somebody doesn't actually teach Celsius to Kelvin, but on your formula chart. Yeah. Okay. So how are we feeling about this? You need more time, or are you good? Looks like some of you are still scribbling. Move on? No. We got a little bit of time left. I'm gonna press my button. Button's not working. Oh, button. You had a good run. Brought you all the way from Oregon when I started teaching.
We're good.
Button technology has probably improved over the last 20 years, so I'm sure I'll get something from it. Okay, there's these things called derived units. Derived units are functions of other units. So volume is a derived unit because in physics volume is the product of 3 dimensions: length, width, thickness. Okay. And density is also a derived unit, the quotient of mass and volume. And again, density should be rho, but it's on your formula